decay. Well, so earlier I said y equals y naught times e to the kt. Yes, if you look at the physics book or math book, this is the most favorite type writing. Okay, so this y naught is the initial amount. Initial amount. So that is what? 800. Okay? Y is as time goes, as you see, it is decaying. Alright? It is decaying. So 800 grams to 400 grams, it becomes what? Exactly half. Well, in money problem, we talked about what? Doubling time. But in physics, in decay model, we talk about half-life. We call it half-life. Alright? So what can you say? 400 equals initial amount is 800 and e to the kt. We don't know what that is, what k is, but what is t? T is 2.5 years. Yeah, we are using 2.5 years later. So 400 equals initial amount and e to the unknown here constant over here, and the time variable shows it 2.5. So how do you find the k? So number one, can we guess that this k has to be positive or negative? Can you think of that? Yeah, it's going to be negative because it's decaying, it's decreasing. Okay, we expect the k to be negative. So let's divide both sides by 800. So this gives you 1/2, but 0.5 is faster when you do on your calculator. So this cancels e to the k times 2.5. So what is that? How do you solve this equation? Yes, we are going to convert that. So again, ln 0.5. Yeah, take a log. ln 5 equals k times 2.5. So what is k? K equals ln 0.5 divided by 2.5. I said we are going to expect a negative value, but I don't see any negative. But guess what? This ln 0.5 can be negative. So let's see, ln 0.5 divided by 2.5. Yes, that gives you negative 0.2773. Okay? Negative 0.2773. So what is the equation? Y equals y naught, here is 800 e to the what? Negative 0.2773 t. This is the equation that models this particular radioactive substance. Okay? If you change it to another radioactive substance, for example, uranium or titanium, okay, those things, then if that is the case, this constant will be different. Okay? And always we are going to use the initial amount. Okay. The next one is that how much of the substance will be present after 4 years? After 4 years. So what does it tell you? Yes, they gave us t equals 4. This is given. So we are going to do what you need to do. Just plug in over here. Okay? So we compute 800 times e to the negative 0.2773 times 4. Got that? Okay? So that gives you roughly 264.17 grams. Okay? So, yes, we saw both increasing model and decreasing model. Okay? Well, this is the conclusion of this course. Okay? As I said, I'm not going to do the other problems. Well, this is enough. And in terms of this money calculation part, this interest part, well, when you go to finance area, you are going to use only compounding continuously. Okay, no other things are not really practical, so that's why I just skip those areas. All right, so here, well, let me be honest. I would not ask anything serious one in the final exam. Okay, I may ask you like this. I give you model and how many years, so many years later, what is going to be the quantity. Just to put it in there. That part would be okay, but other things, just I want you to at least, oh, I saw that in college algebra class, and then now I'm going to use it again. Okay, when you go to next time, it's going to be the same amount of work. Okay, there will be no like miracle to solve this one in, you know, just in one button. No, there will be none case like that. Okay, so I want you to just remember you can do decay model and the growth model both with the exponential functions. Well, let's start review. Number one, I want you to remember that final exam is on MyMathLab, and you are going to upload what? Upload your scratch paper on Canvas. Okay, on Canvas here. Without that, well, I cannot regard that you really took the final exam. Alright? Okay. So I'm going to send you an email about this one more time. The first page is everything about equations. Number one equation is about the circle. Okay. The points -1, 2. So -1, 2 and 5, 10. This is the end points of the diameter of a circle. So when you connect this, this is a diameter. Okay? So what does a circle look like? Well, circle will look like this. I'm sorry, it's not that great, but okay. So when you have a circle, you need two things. One is a center, and how large is a circle is determined by radius. Of course, radius is diameter divided by 2. So which one is easier to compute here, center or radius? I would say center. Okay. So center is what? The midpoint of this. Midpoint of these two endpoints. So x coordinate is average of two x coordinates. So add up and divide by 2, which is 4/2 is 2. Y is 2 and 10, so you add up and divide by 2 gives you 6. So in other words, the center turns out to be 2, 6. Okay, so this is a center now. What is a radius? Again, the radius is the from this amount. So what are we going to do? I'm going to compute diameter first. Okay, compute the diameter, and then divide by 2. Okay, divide by 2. So this is my game plan. Even though I know the center, just in case if you make a mistake, what am I going to do? No, you don't want that. So I'm going to use this. So diameter is distance between these 2 points. So 5 subtract -1, so gives you +1 squared. 10 subtract 2 squared, which is 6 squared plus 8 squared. Does it sound familiar to you? 36. and 64. That makes square root of 100. That gives you 10. So now this diameter is 10. Be careful, okay? So what does it say? R equals 5 over here. Okay? So R equals 5. Yes. So what is the equation? Now the equation of a circle is x minus h squared plus y minus k squared equals r squared at h comma k. This is the center of the circle, and of course r is the radius. So here we go. X minus 2 squared. You see, when you have a 2, you x minus 2. And here, y minus 6 squared equals r squared, which is 5 squared. So you can say that that is 25. Okay. Next one is logarithmic equation. Here, number 2. Log x plus 15 plus log x equals 2. Well, this logarithmic equation, one side we have 2 logarithms, the other side we have just number 2. So what is your game plan? Yes, we are going to combine these together, make a single log. Yeah, we verify the bases are the same, 10. So x plus 5 times x equals 2. So what are you going to do when you do not have a logarithm on the other side? If there is a logarithm, we just compare. Without logarithm, yes, only one way. Yes, that is conversion. So here the base, invisible base is 10. So what are you going to do? Yes, 10. Make the same base 10 to the second power. Yes, go bring the 2 to the side. So 10 to the second power is x plus 5 times x. So 100 equals x squared plus 5x in short. So now it becomes a quadratic equation. So when you have that, that is going to be, you're going to make one side 0. So x squared plus 5x. Subtract 100 from both sides and make a minus 100 equals 0. How are you going to solve it? Either you factor or quadratic formula, but in this case, yes, factoring is a very easy one. So we are going to look at this one as 15, I'm sorry, not 15. Yeah. Oh. So 5 or 15? I'm sorry, it's 15. Yeah, 15. Yeah, that's why I keep saying 15 and this. Okay, 15. So now its mystery is over. So look at this negative 100 as negative 5 and 20. Multiply and then negative 100. But when you add them up, this is going to be, this is 15. So this is x minus 5 times x plus 20 equals 0. So that gives you x equals 5 or x equals negative 20. Well, this is not the end. Okay? So what is waiting over here is that whenever you have a logarithm, all these argument has to be positive. Every argument has to be positive. So plug in. 5 will not cause any problem. So 5 is check mark. That's fine. What about x equals negative 20? As soon as you put in here, oops, no, this is negative 20, it will not work. Okay, so it has only one solution, that is x equals 5 over here. Oh, by the way, when you put 5 solution here, do not write it x equals 5. Don't say that. Just 5 in there. Alright? You may lose point in on my math lab. Okay, let's continue.